Now let's take another example with friction involved and how to apply Newton's third law in this case. We have two boxes A and B, same material, different mass, placed next to each other on a horizontal rough surface, which means rough means there is friction involved, or if any surface that's not mentioned in the problem to be frictionless, that means there is friction. An applied force acting on box A causes both boxes to accelerate 2.6 meters per second squared to the right. If the magnitude of the force exerted by box B, magnitude of the force of friction on box B is 28.3 newtons, he give you the friction force. Calculate the force exerted by box B on box A. We start free body diagram on box B, in this case, not the whole system. We use box B, free body diagram. We apply Newton's second law of motion. Then we find Fa on B. Then we go to third law of motion for Newton and we find Fb on A. As simple as that. Box B, there is a gravitational force and there's no normal force pointing upwards. Set your directional dimensions or convention for directions. Right and up are positive. So we have on the right F exerted by object A on B, going to the right, and there is F of friction on B, which is going in the opposite direction of motion. If you draw a forces schematic or a vector schematic, we have Fa on B and we have F friction on B to the left direction. F net will be going to the right. What is given? You have mass of A 6.5 kilograms, mass of B 8.5 kilograms, the force of friction 28.3 newtons to the left, acceleration for the system 2.6 meters per second squared to the right. Find the force Fb on A, force exerted by box B on A. Analysis. We drew the free body diagram for box B. We found that the F net horizontal Fa on B plus F friction on B, and that became F net horizontal equals, without direction, Fa on B plus F friction on B. Vertical direction is ignored. All motions are horizontal in this case. Newton's second law will tell you, instead of F net horizontal, that would be the mass of the box by the acceleration equals Fa on B plus F friction on B. Fa on B, if you rearrange, would be mass of the box by acceleration minus the F friction on B. We know all these variables, 8.5 by 2.6 minus the minus 28.3 newtons. Then that means the force exerted by A on B would be 50 newtons to the right. Now Newton's third law say Fb on A is minus Fa on B. So Fb on A would be minus 50 newtons or 50 newtons to the left. As simple as that. Now it's good to mention that in rockets, Newton's third law is involved with a certain convention. If you understand the mechanics or the science or the physics behind rockets, there is a jet engine over here that is blowing away a lot of heat and pressure to the back. So that is considered as the force of action, and the rocket will go up or will go to the right as a force of reaction. In the first glimpse, you will think that the rocket is going as a force of action upwards and the reaction will be downwards, but it is, if you look at the physics and how rockets work, you have a couple of engines or 3 engines back here pushing jet of force and pressure to the back or to the earth in many cases. That would be force of action that is pushing the rocket to go upwards or to the right in this case as a reaction.